Sun is a normal main sequence G2 star, one of more than 100 billion stars in our galaxy. We live on the planet, so we think it's an equal member of the solar system, but that couldn't be further from the truth. The reality is that the mass of Sun accounts for 99.8% of mass of the solar system, and most of that final 0.2% comes from Jupiter. So the mass of Earth is a fraction of mass of the solar system. Really, we barely exist. If you could take apart the sun and pile up its different elements, you would find that 74% of its mass comes from hydrogen with 24% of helium. The remaining 2% is includes trace amounts of iron, nickel, oxygen and all other elements we have in the solar system. In other words, the solar system is mostly made of hydrogen. We know of some amazingly large and bright stars like Eta Carina and Betelgeuse, but they are incredibly far away. Our own sun is a relatively bright star. If you could take the 50 closest stars with 17 light years of the Earth, the sun would be the fourth brightest star in absolute terms. Not bad at all. With a diameter of 109 times the size of the Earth, the Sun makes a really big sphere. You could fit 1.3 million Earths into the Sun, or you could flatten out 11,990 Earths to cover the surface of the Sun. That's big, but there are some much bigger stars out there. For example, the biggest star that we know of would almost reach Saturn if it were placed inside the solar system. Astronomers think that the Sun and the planets formed from the solar nebula about 4.59 billion years ago. The Sun is in the main sequence stage right now, slowly using up its hydrogen fuel. But at some point in about 5 billion years from now, the Sun will enter the red giant phase where it swells up to consume the inner planets, including Earth probably. It will slough off its outer layers and then shrink back down to a relatively tiny white dwarf. The Sun looks like a burning ball of fire, but it actually has an internal structure. The visible surface we can see is called the photosphere and heats up to a temperature of about 6000 degrees Kelvin. Beneath that is the convective zone where heat moves slowly from the inner sun to the surface and cooled material falls back down in columns. This region starts at 70% of radius of the sun. Beneath the convection zone is the radiative zone. In this zone, heat can only travel through radiation. The core of the sun extends from the center of the sun to a distance of zero point 0.2 solar radii. This is where temperatures reach 13.6 million degrees Kelvin and molecules of hydrogen are fused into helium. It feels like the sun has been around forever, unchanging, but that's not true. The sun is actually slowly heating up. It's becoming 10% more luminous every billion years. In fact, within just a billion years, the heat from the sun will be so intense that liquid water won't exist on the surface of Earth. Life on Earth as we know it will be gone forever. Bacteria might still live on underground, but the surface of planet will be scorched and uninhabited. It'll take around 7 billion years for the sun to reach its red giant phase before it actually expands to the point that it engulfs the earth and destroys the entire planet. Unlike the planet, the sun is great big sphere of hydrogen gas. Because of this, different parts of sun rotate at different speeds. You can see how fast the surface is rotating by tracking the movement of sunspots across the surface. Regions at the equator take 25 days to complete one rotation, while features at the poles can take 36 days, and the inside of sun seems to take about 27 days. The surface of sun reaches the temperature 6000 Kelvin, but this is actually much less than the sun's atmosphere. Above the surface of sun is a region of atmosphere called chromosphere where temperatures can reach 1 lakh Kelvin, but that's nothing. There's an even more distant region called corona, which extends to a volume even larger than sun itself. Temperatures in the corona can reach 1 million thousand.